Hi, and welcome to our video on how to measure voltage with an Arduino. We start pretty simply, and then we get to a more advanced setup that allows you to measure voltage with great accuracy and in sort of much more stable way. So what's the simplest thing that you can measure? We can see Arduino nicely recording voltage here, somewhere around 1.5 volts. Yep, so that's great. The voltage is a bit volatile. What does it actually measure? So yeah, let's have a look. Yeah, so as you can see, it's measuring absolutely nothing, or thin air, if you want to call it this way. What in fact it actually measures is electrical interference. It's picking up from around the area, so we can move things around and see what happens. So if we just grab this lead, it immediately drops voltage to 0. Grab the other lead. Doesn't do quite as that, but yeah, it's picking up, it's acting as an antenna and picking up electromagnetic field, and the voltage changes depending what we get close to. So there's a lot of it around, especially coming in from the power source that powers the Arduino, the laptops, all electronics around, including lights, and the AC in the sockets as well. So yeah, this is the easiest thing you can measure. So what is absolute minimum code we need to actually read this voltage? We actually need these two lines. One to read analog signal from, in this case, pin A0, could be anything between A0 to A5, and then to convert the analog read into a voltage. In this case, it will be in millivolts because we're looking at whole numbers. So we just use the Arduino framework's built-in map function. So we say that the analog signal can be anywhere between 0 and 1023, and the voltage that we can read can be anywhere between 0 and 5000, which is 5000 millivolts, which is 5 volts. And the rest of the code is just there to really print things. So we get on line 4 in a setup, we get a serial begin, where we just set the baud rate so we can print our results. And then line 11 and 12, we actually print the voltage. We divide it by 1000 here just to make it like into voltage format, so we don't get large numbers. It actually get a fraction in volts. And the delay is simply there to make sure we don't read voltage every millisecond over and over and completely flood our logs. So you can set that to wherever you prefer. So that's the basic of it. So what's the effect of the analog read is on our measurement? Because we get the values from 0 to 23 and it's only going to be a whole number, we know that we cannot measure a change any smaller than 4.9 millivolts. And how do we know that? We just divide 5000 by 1023, and we know that for every sort of 4.9 millivolt change or increase, we're going to get increase of 1 in this value of the analog read. And that's the limitation of our 8-bit ADC. This is as much resolution as we can get. We can get to that later, but that's enough for most of our cases, most of our needs. And if it's not enough for you, there are many ways of improving your accuracy, improving your resolution, which we will get to later. Let's see a simple code in action and see how useful we can make it, especially for measuring something like an alkaline battery. They are like an outdated technology in a way, but you might still have some of them around, and it's a good thing to start with, a good thing to play around with. It's relatively stable, voltage doesn't change all that much. So what we can get is a positive cable connected to positive here on the breadboard, negative to ground, and we connect the ground from Arduino to the same ground rail, and we get the A1 pin to the positive of the battery. We also connect these two leads of the chip multimeter in parallel, just so we can compare the voltage reading that we get in Arduino and see how close or how far we are from what we get from multimeter, just to double check whether we're generally on the right track. So yeah, the code is simple, the setup is simple. Let's see how that goes. Once you upload this basic code, you can see that the results are pretty similar. It's hovering around the 1585 area, which is, close enough. Quite a few millivolts off, but it's fine. You cannot really tell which one is more accurate or not. Except we can, because if we compare and check this voltage with a different multimeter, just to double check, we get the same reading. So it's definitely the multimeters are correct and the Arduino is slightly off in this case. Let's say we want to measure voltage which is less than 5 volts and in fact closer to 1 volt. So like actually below 1 volt. What do we do in that case? Well, let's just get our basic code. Let's delete this, divide by 1000. So we actually get the millivolt voltage value. And let's see how that goes for the full setup with something like a solar cell. Let's see how that goes. Yeah, so this is what we get by default when we measure reasonably low voltage. The Arduino gives us, what is it, 40 millivolts. And well, the multimeter gives us 52, 51. So yeah, you can say it's close enough. There's only 10 millivolts off, but if you look at percentage-wise, it's like whatever, 20%. So yeah, it's accurate enough depending on your use case. So what if we actually use the internal reference and use actually a lower reference voltage and try to get a higher resolution, higher precision? Let's see what happens then. So what do we need to change in our basic code to actually use the internal voltage reference? We can start by getting rid of this whole fixed 5000 value because our voltage reference is not going to be always 5 volts or 5000 millivolts. It can change, and in fact it often does, so we'll get to that in a bit. So let's declare this as a define. So we can just say, yeah, let's just say it's a defined value of voltage reference of 5000, and let's use that value instead. So far nothing changed. So now let's use the actual analog reference function call and use the internal. This is just comes from Arduino documentation. I'll show that in a bit. And let's do a single analog read. I will explain why we need that in a minute. But yeah, it's best to just do that once. And then let's change the actual reference voltage that we use. So Arduino documentation defines it's going to be 1.1 volts. So it's 1100 millivolts. On this specific Arduino, it is different because we measured it to be different. We'll explain how to do it in a sec as well. So let's change that to what the value we actually get. And yep, that's this way we actually get the measurement of the voltage with using internal reference voltage. Let's see how that goes. And as you can see, the voltage is much more closely resembles what we get on multimeter. We get like 52, 53. It does vary it a bit, but we are much, much closer. So we can kind of improve stability of that for multi-sampling, and then we get almost the same values as multimeter. But you know, that's not for the specific case. So what we get is a much better resolution. We can get like a millivolt precision. So this matters in cases when you actually the voltage actually changes. So let's dim the light gradually. And you can see it dropped and dropped again. And yeah, we picked that up. So we won't be able to do nothing nowhere near as accurate at a higher voltage. Well, a higher reference voltage. So in cases like this, when you want higher precision, higher resolution at the low voltages, using internal or lower reference voltage is very helpful. So let's dim it all the way down. And you see how much it dropped. And dim it back up, light it back up. So this is useful for specific cases like this, when you sort of get in a very low voltage of either a sensor or basically you get in checking a voltage drop over a small resistor. Yeah, in cases like that, it can be used. So let's see how we derive our internal reference voltage. So we look at Arduino docs that for analog reference, and it just says to use internal. So basically call the function and pass the internal as a parameter. So going back to our code, we can see that it's pretty straightforward. We just make that function call, analog reference, pass the internal value. So once we upload this code, all we need to do is to connect the ground to the ground of a multimeter, and then the positive to the AREF pin, which is just sort of right here. And then we can read our reference voltage. And this is, once we upload the code, what we see is 0 or, minus 0.001 here. So yeah, that doesn't work. All we need to do is to read the voltage once, like this. Let's upload this change. And let's see what happens then. So yeah, this is actually explained a bit in documentations for Arduino that first few reads will be inaccurate. but in this case, it's not inaccurate, it's just always 0. So you just have to read it once to set up, and that will do. So you can see our internal reference voltage is not 1.1 as documentation suggests. Let's go back to docs. It suggests that it should be 1.1. And ours, in fact, is, well, 1.11. And yeah, we need to change that. Well, we need to use the right reference voltage whenever we're measuring things. So briefly getting back to the code that we used earlier, this is why our reference voltage is 1.11 volts and why we have a single analog read at setup stage. Now let's switch from reading internal reference voltage to just the default, which will be around 5 volts. So let's get rid of that. And we still have to keep this single analog read to make sure we actually getting that updated. Let's upload the code. Let's see what we get. Yeah, it's changing, and yeah, we get 5.12. So we actually, if we use the 5 volts as we use by default as a reference voltage, we get this inaccuracy. So this is how we can actually, well, improve the accuracy of the Arduino voltage measurement or any kind of analog signal management for free, effectively, by using the correct reference voltage. Unfortunately, we can only measure it externally. You cannot measure your own reference voltage with an Arduino because it's always going to be the 1023, sort of the maximum of your ADC value, because your maximum is always equal to your reference voltage. So you have to use something like this external to measure it once. And yeah, but that helps. Let's see how that improves our accuracy. Now, after we upload the updated code with the new voltage reference, we can see that's actually much closer to the true value. And if we put this pin back to measure the voltage with this other multimeter as well. Yep, we get the 163 here, and we get the 163 on an Arduino. So that was the source of our inaccuracy. So now that can be fixed. Except there is one other slight problem. The voltage reference that we get is from a power supply, in this case indirectly from the laptop. So what happens when that changes? Well, let's zoom out a bit and see where we're getting the power for this Arduino. And we getting this from the USB hub, which is connected to the laptop. So what happens if there is a different device connected to this USB hub and it's draining the energy? So let's say we connect this LED light. Immediately we can see that the voltage that is measured by the Arduino has jumped to 172, and neither of the multimeters record any change in the actual voltage of the battery. So how we can explain that? Well, our reference voltage must have changed because we're now getting a lower supply of voltage to an Arduino. So let's check that, if that's the case. Make sure we get to the red pin here. It's the third one, this Arduino. Yep. So we can see that our supply voltage is now 484. It actually has dropped, which is why we're showing a much higher voltage reading. So let's change that. So let's change this to 4840. Re-upload the code. And what do we see? Yep, and the voltage is now back to normal, basically, which is great. So yeah, once again, we're getting a more accurate value, I mean, the actual accurate value. Unfortunately, when we disconnect this, we have to then again reapply the same code change. And yeah, that's a general problem with an Arduino power supply. And the only way to get around that is to use a more stable voltage reference. So an Arduino internal reference voltage is stable and we can use that. Slight problem is that we can only then measure voltages up to 1.1 volt. And to get around that, we might need something like this, a voltage divider or a voltage sensor, if you want to call it that, to effectively magnify the range of voltages that we can basically cover. So usually it's used to increase from 5 voltage limit to 25 voltage limit, but in our case we will use the same 5x multiply effect to get back to 5 volts basically, or 5.5 in this case, because of basically 1.1 volts to start with. So let's see how that goes. Now, once we update our setup, it looks like something is broken, because we get voltage measurement which is a straight line, And not sure why that happens. Yeah. Except everything is actually correct. So if you look at the bottom right, you can see that the number of observations keeps going up and up and up all the time. We're getting close to 200 of them. Yep, we just reached 200. And every single time it is 1.63. So basically it actually is recording the right voltage as expected. Now let's test the effect of introducing LEDs to the power source, just like we did last time. So let's use the same LED. Let's pop it over there, and we connect it to the same USB power source. Yep, you can see the lights are on, and again, there is no effect on the battery voltage, and there is no effect at all on the voltage that we read on the Arduino, which is great, which is what we want. So let's connect it again. Again, nothing changed. Perfect. So how did we achieve this stable setup? The wiring is pretty straightforward. So we're using this voltage divider or voltage sensor, if you want to call it, just like it's normal to use. So basically we're getting the positive and the negative to the same rails, and we're getting the negative connected to ground of the Arduino, and the signal pin to the A0. So basically, this is to increase our voltage range from 1.1 volt of our reference voltage to 5.5, basically getting 5x. And there are just some small changes to the code. So let's look at that. So first of all, we multiply our reference voltage by 5. By the way, why are we getting the 5x increase in range for the voltage? This is because of resistor values that we have on this standard voltage divider. We get 32K and 7.5K. And if you use this formula, then you end up with basically 5. So that's a 5x improvement that we get. We also need to, read the analog voltage. It's better to do that twice, just to be on the safe side. And also we can re-add back this whole divide by 1000, because now we once again reading high voltage, not millivolts anymore. And yeah, this whole setup works, and it's pretty stable. Just to once again look at the setup, just to kind of marvel in its stability. We'll move things around just so you see that it's not a freeze frame. It's constantly 1.63 here, and constantly 1.63 as we get inside the Arduino. It just doesn't change. Well, as it shouldn't be, because the battery voltage is stable. But yeah, our internal reference voltage is also stable in this case, which is how we want it to be. So yeah, if this works out for you, then you might want to learn how to measure current, which is something we already covered in this video.